Does anybody have homework questions? Yes.
Chapter 8, section 8.2, mine's related.
So we have a dime and a quarter being flipped. If we see two tails, we ignore the flip. If you see at least one head, record whether you see one or two heads. Repeat this experiment 30 times, and approximately what fraction of flips do the two coins show double heads? So in this answer, you'll not put what you see in your experiment, but your experiment should hint at what the real probability is. Let's go ahead and calculate the real probability, and then you can enter that instead of the relative frequency. I have a note here that you're having one special study group on Monday. So we don't always have study groups on Monday, but this Monday there will be a study group. So you can fit the one in on Monday and on Wednesday to prepare for your last quiz. If that doesn't fit for your schedule, feel free to email the tutors for a Skype appointment, or
so there's no study
email
group
me.
next Wednesday?
There is a study group Wednesday also, Monday and Wednesday.
Sadly, I can't make it to the Monday one.
So let's write out the possible outcomes from flipping a dime and a quarter. So they could both be heads, they could both be tails. One could be tails and the other heads. Now we're supposed to ignore one set, but now I'm not on my video, so I can't tell anymore. I'm not on Wiley Plus. What are we supposed to ignore?
I think it's like two tails.
Was it two tails? Okay. So this one we ignore. So the possible outcomes now are just three, because we're ignoring outcomes with two tails. Out of those outcomes, how many are both heads? One, yeah. So put 1/3 in Wiley Plus. If that's your last chance, if it doesn't work, let me know. Or if it doesn't work anyway, let me know. Did it work? Okay. What other homework questions do you have?
Could we do 9.2?
We're not done with 9.2, so I changed the due date for 9.2 to be
15?
yes. So we should finish up things like the 5-number summary today, and then you can finish that in your 9.2, and we can go over questions next week. Any other questions from Chapter 8 or 9.1? Today we're going to make sure everybody understands how to make a histogram. We're going to look at histograms on the textbook, in the textbook here. So we're all about making our data visible. So here you see big blocks of data, and of course it's made more visible in these histograms. So we started making histograms, and we'll go ahead and take out the one we made on Wednesday and label it. But first I wanted to look at some histograms that are bell curves. So this histogram shows the frequency, as all histograms do, the frequency of heights. Did you know when you measure something, your measurements are not necessarily always going to be the same? So we're measuring the height of one person here, and these measurements are not always the same. Now maybe the person slouches a little, maybe your measuring tool's off a little tiny bit on one or two of these. This is done 100 times. So this is a typical bell curve shape where the mean and the median will be in the middle in this. So what we can find out about bell curves is how widely the data is distributed. So these are batting averages in 1920 and batting averages in 2000, you see the one in the 1920 are spread out more, and the ones in 2000 are clustered closer together. So how far the data is distributed is called, who knows what it's called? Anybody? Variation, okay? So data tightly bunched together will have a small variation. Data spread out more will have a large variation. So when you hear people talking about variation, that's what they're talking about. Some other things that can happen with your histograms, you could have most of the data on the left, like this one. So this one is biased toward the left. Or you could have two populations, and then that's called bimodal. So you'll have some homework questions asking you about if it's skewed to the left, like this is, instead of a bell curve like we saw in the baseball batting problems. Or it could be skewed to the right. I don't know if there's one down here skewed to the right. I don't see one. Or you can have a bimodal distribution where there's two distinct sets of data, as you see in this example with 7th graders taking the SAT and 11th graders taking the SAT. Well, let's go back to our histogram and label what parts I'll be looking for when you make a histogram on the quiz so that everybody can get full points on the quiz. So hopefully you made this with us in class on Wednesday or with the video on Wednesday. So let's use a different color to label the parts that I'll be looking for when I give you grades. Okay, so it should have a title. It should, a histogram should always list frequency on the vertical axis. You can say frequency using different words. I believe one of the histograms in the text says number of students, okay? But the idea is that you're getting the number of something happening. So your bins need to be consistent in size. So each one of our bins was 50,000. We don't try and make some bins 10,000, some 100,000 to group things up. No, we want the consistency because that's what we're displaying. We're displaying gaps in consistency. For example, this big gap. So there's another thing. No breaks or skips. We didn't skip that. And you should have a title. Okay, so you have a title on the bottom axis, a title on the top, and the frequency title on the vertical axis. Another thing is there's no gaps, no spaces between bars. I don't spread out the bars. We clump them all together, squish them all up. The only qualification for that is, of course, if there are no bars within that data set, then that's different than spacing the bars out. Sometimes students want to space the bars out. Don't do that for a histogram. Okay, so these are all the aspects of a histogram that I'll be looking for. And now you'll have an opportunity to make another histogram and make sure you remember all of these aspects with the grade data. So we had another set of data, Math 101 final exam grades. I'll put this down and you can go ahead and make a histogram. And then we'll compare histograms when you're done. Everybody use bins of 10 here, okay? 1 through 10, 11 through 20, 21 through 30, please. I'm going to take mine off and make one too. Once I get mine made, I'll come around and see how you're doing. If you're stuck, raise your hand, okay?
I just want it's like I'm dumb or something.
No, you're not. So make a bin, listing grades. Make bins and list the grades in the bins. Like how many are from 0 to 10, how many are from 10 to 20, how many are from 30, 20 to 30, and so on, okay? So that you can have data to make bars with, okay?
And then what is this?
That's in case some students did a little differently, but this is what I suggested, okay?
And then how would I what stuff goes where on the graph?
So once you have those bins, then you're gonna make bars. So you're gonna put a title here that says frequency. Okay, so you're gonna have frequency. And you're gonna have a title here that says grades. And so this is frequency graph of final exam math 101 grades. Anybody else stop?
Yeah, I'm kind of stuck with trying to make intervals of 28, 42, by 4s and stuff.
Yeah, don't do it by that. Do it by tens.
Oh,
Do it by
okay.
10. Groups of 10.
Alright.
0 to 10, 11 to 20.
I'm just gonna do 20, start 20 to 30 and all that.
No, 0 to 10, 11 to 20. Okay, do it in tens. Okay? This would be, 1, 2, 3, 4. Okay. So some of you are just needing titles yet. That's good. This title on the top, that's the frequency up. But otherwise, it may have a different thing that you know. I don't know if you actually have a frequency. Did you make it yet? So set up something like this. I'd love to see how many are in each grade category, 0 to 10, 11 to 20, and so on. And then that's how far your bars are.
I didn't do that. I'm sorry.
Yeah, I know.
But I mean, I won't have to say.
So you should set up a bin to show you how many go in each category. So here's my bins, okay, 0 to 10, 11 to 20, and so on. And then when you know how many go in each category, then you can make the graphs. So once you know how many go in each category, then you can make the graph. And most of you look like you're getting it really well. So you have your title. It should say histogram of, and then so on. I think I might have misspoke and said frequency of earlier, but it's histogram of. And then you should say frequency on the vertical axis, title, what's on the bottom as grades. And your bins are to sort that data. So you find there's no grades up to 20, and then between 21 and 30 there's 1 grade. From 31 to 40 there's 2 grades. And that tells you how tall to make your bars then once you've made those bins. Does anybody have any questions? If you're online watching and you want me to look at yours, send me a photo, okay? So that's histograms. Those are keeping track of the number of items in each column. Now we're going to look at making a box and whisker graph. So there's the box and whisker graphs are very helpful for comparing sets of data. Sometimes a bar graph just doesn't show as much as a box and whisker graph will. So let me show you some examples of box and whisker graphs. This is 5 different box and whisker graphs. You're only going to have to make one. But as I mentioned, box and whisker graphs are nice to compare data. So I had 2 Math 101 classes that were having this very similar mean. And so I wasn't able to tell just from their grade mean how they were doing. So I made these box and whisker graphs and compared. Because what these do is, what we have in the box is 50% of the grade that's clustered around the mean, which is the horizontal line here. We're going to be doing ours this direction. So you have 50% of the grades, or in this case, 50% of the speed of light being calculated, clustered around the mean for each experiment. So for me, when I did this with two different classes to compare the teaching techniques, even though the means were similar, I could see that the students were pulled up higher, that 50% of the students were pulled up higher, and it was nice to know that and to pick one. So what we have is the mean in the middle as a vertical bar. Well, not necessarily in the middle, but you have the mean set as a vertical bar, so this mean is between 900 and 1,000. Then you'll have the first quartile and the third quartiles as these other vertical lines, and we're going to have to look and see, well, how do you find those? So 25% of the speed measurements fell in this box, this first between the first quartile and the median, and 25% of the speed measurements fell in this box between the median and the third quartile. And then what you have at the end is the max and the min and a little dotted line going to the box. So it's showing where the spread of your data is falling and where half of it is falling. This little dot out here is what we call an outlier. So some pieces of data are very far from the most recent piece of data, and so we put them as a little dot out here. Let's go ahead and try one of these, okay? And then hopefully you'll get the hang of what we're doing. So we'll go ahead and use the prices of the homes sold recently near Green Bay. And first we have to find 5 number summaries. So I guess before we even get to those specific data, let's make sure we know how to find 5 number summaries. So we're looking at finding 5 number summaries of data. So let's just take a small data set. We'll take 18, 22, 17, 19, 25, 62, 48, and 51. So here's some data. I'm not even telling you what it is. We're just going to use it to find the 5 number summaries. So the first thing you'll do, and you'll get a data set like this on your quiz, okay? So the first thing you'll do is you'll order it. So order it in increasing order. So the smallest number is the 17. Then we have an 18, a 19, 22, 25, 48, 51, 62. Now count your data and make sure you didn't miss any. So still have 8 pieces of data, so we didn't leave any out. It's really sad on a quiz when you leave one out and then you don't get the right answers. Okay, so the 5 number summaries are the min, the max, the median, the first quartile, and the third quartile. So the minimum is the smallest. The max is the largest. The median is the middle number, which we already talked about. And if there's 2 middle numbers, then we average. So that's the median. And then we have the new numbers that we haven't talked about yet. Well, I guess min and max we hadn't talked about, but those are pretty self-explanatory. The first quartile is the median of the smaller half. The median of the smaller half. The third quartile is the median of the larger half. So the median divides your data in half, and then we divide the data in half again. So we get quarters. Okay. So let's take a look here. Here we have, where's my red pen? Here we have the min. Here we have the max. And we divide this in 2 with a vertical line, just like we did with finding the median. So we have 4 numbers that are smaller to the left of the vertical line and 4 numbers that are larger to the right of the vertical line, like we did with the data for our homes and grades. Okay, so to find the median here, we're going to have to average 22 plus 25 divided by 2. 22 plus 25 divided by 2. 47 divided by 2. I think it's 23.5, but I'll just double check. Yeah. Okay, and now we have the median, and we have our data divided in 2. So now we're going to find the median of the 4 smaller numbers and the median of the 4 larger numbers. So the first quartile, we'll have to average these 2. Okay. So first quartile. So we'll average the 18 and the 19. Because there wasn't one single middle number, so we have to average those 2. Okay. 18 and 19 divided by 2 is 18.5. So that's the first quartile. And then we have 4 numbers to the right that are larger, and we're going to break those in half as well. So divide it in 2 and find the median there. So there's 2 middle numbers. We average those. 48 plus 51 divided by 2. 48 and 51. Let's just use a calculator. $49.5. So finding those 5-number summaries is the most work, and graphing is the least work. And so we're going to practice a couple more 5-number summaries, especially because depending on how many numbers you have, it makes it a little weirder or easier finding the 5 numbers. So let's try another data set. Does anyone have a question on these? Okay, this was the third quartile right here. 49.5. So here's another example. I'm going to make a little bigger data set. I'll just write them in order because presumably you can write them in order. I'm sure you can. So I added one more number now. We have 9 numbers: 17, 18, 19, 22, 25, 35, 48, 51, 62. So this time, since we have an odd number of numbers, an odd number of data, what is the median?
25.
Good, the one right in the middle, 25. So we have the minimum and the maximum. Okay, you can write those down, right? The min and the max. 17, 62. The median was the number in the middle, 25. And here's where it gets a little tricky, and I wanted to point out the difference between an odd data set and an even data set. An even number of data points versus an odd number of data points. Here we just divided in the middle and we had 4 on each side. We do that with this as well. We just exclude it. This is the middle, and so we still have 4 on each side in this case. Okay, 4 numbers to find the median of for the first quartile, and 4 numbers to find the median of the third quartile. So if you have an even number of data points, you draw the line down the middle and look at the bottom half, the lower numbers, and the top half, the larger numbers. If there's a single number in the median, you just exclude it and you still divide that way, only you've crossed off the median from your list as you calculate the quartiles. So I believe the first quartile is still going to be averaging 18 and 19. Yep, that's right. And the third quartile, we're going to average 48 and 51 again. Here, I'll add one more number, and this time you can find the 5-number summary, all right? Does anyone have questions first? Okay, so same list with one more number. $17, 18, 19, 22, 25, 35, 40, 48, 51, 62. Okay, so find the 5-number summary, please. So the min is the smallest number and the max is the largest number. So 17 and 62. How did you find the median this time?
You have to average it.
And what did you average?
25 and 35, I think it would be.
Yep.
No, it'd be 30 as the median.
There's no 30
Oh,
in the number set.
35, 35. Oh.
So yes, 30 is the median. Good. Okay, so then since there were two, you should divide. So you have the 5 to the left of the vertical line and 5 to the right of the vertical line to find the first quartile and the third quartile, the median of those two sets. So what was the median of the first quartile? Anybody? 19. The number in the middle of those 5 numbers. And the median in the larger set of 5 numbers? 48. Good. Okay. So if you're averaging to find your median, then divide up your data set right in half between those numbers when you're finding the first and third quartile. If your median is just a single number in the middle, then exclude it from the the smaller 4 numbers and the larger 4 numbers. Okay, a single number for the median. Exclude it when finding the first and third quartile. Okay. Single value for the median, exclude when finding the first quartile and the third quartile. When averaging to find the median, leave the two data values in when finding the first quartile and the third quartile. So the one number would go in the lower half of the data and the other number in the upper half. So that's the only tricky point that comes up finding these 5-number summaries. What to do with those medians. Let's go ahead and draw a box and whisker graph now that we know how to find the 5-number summary. Do you have any questions first? So first we'll do the 5-number summary for the prices of homes sold recently near Green Bay. So we have the min, the max, the median. Then the first quartile and the third quartile. So the minimum, 65,000. Maximum, 669,000. Median we found in class, we averaged the 15th and 16th piece of data. Okay, because there's an even number of data here, 30 pieces of data. It came out to 100, well, I'll just show the work again in case some of you weren't there. 188,000. Averaging the 178 and the 188. So because we had to average to find the median, we draw the line down the middle, and the smaller numbers are used to find the median of the smaller numbers for the first quartile. So we have 15 numbers to find the median of. So we pick the 8th number. If you pick the 8th number, you can double check. There should be 7 numbers above and 7 numbers below. 1, 2, 3, 4, 5, 6, 7. 7 numbers smaller than 135,000 and still in the smaller half of the data, and 7 numbers larger than the 135,000 and still in the smaller half of the data. So number 8. Now we'll find the median in the larger set of numbers. So there's 15 numbers again, so we should be able to come to the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. And there should still be 7 numbers that are larger than that. 1, 2, 3, 4, 5, 6, 7. Yeah. So the 3rd quartile is 278,000. So we have our 5-number summary. Does anyone have any questions on finding that? Then take out a piece of graph paper, please. I feel like I set one aside. Here it is. Take out a piece of graph paper and we will make a box and whisker graph. So as always, you need a title, so call it what it is, a box and whisker graph. A box and whisker graph or a box and whisker plot of prices of homes sold near Green Bay recently. Prices of homes sold near Green Bay recently. Now make your scale. So leave a little space for the actual box and whiskers and make your scale. So let's make our scale in 50,000s. So 0 to 50, 100, 150. I think I'm just going to write every 100,000 because it's getting kind of crowded. It might have been nicer to do this in 25s, but okay, it's already done. So title that axis, prices in thousands. And now you have to put your 5-number summary down. Now you have to put your 5-number summary down. There will be no vertical axis. There's no labeling on the left because you're not going to list anything over there. So we just have to get this to scale. So the 188,000 is a vertical line. So be careful where you put it. Right between 150 and 200 is 175. So we want to be a little closer to the 200 than to the middle there. You can make it as tall as you want. I'm just going to make it 4 units tall and use a straight edge. Where did my straight edge go? So be careful with your scale. Use a straight edge, and that's your median. Then your first quartile, again, make that the same height, 4 units tall. So I have 100 and 150. Right in between would be 125. So I want to be a little closer to the 150 than the 125. And I do look at your scale to see if you've marked it accurately, okay? So a little closer to the 150 than the middle. So that's your first quartile. And then your third quartile is at 278. So between 250 and 300 is 275. So we're pretty close to the middle there for 278. That's your box. Those 3 lines, the median, the first quartile, and the third quartile are your make up your box. And then the whiskers are the little trailing ends that go to the min and the max. So the minimum was, where do we have that? 65,000. So halfway between 50 and 100 is 75,000. So I want to be like a quarter of the way in there. And the maximum, 669,000. Whoops, I didn't go far enough, did I? Okay. That's actually an outlier, but I'm not going to have you worry about outliers. So there's a little vertical bar where the min and the max go. 650 to 700, we have 775 in the middle there, so we don't want to be right in the middle, a little to the left of that. So little vertical bar. Whoops, I didn't go up high enough. It should be centered on your height of your box, however tall you made your box. So there's no vertical axis, so it doesn't matter how tall you make your box. So now you're able to see nicely on this graph that half the homes sold in this set of data fell between, it looks like on here about 135 and 275. Just looking at the graph, you can see that half the homes sold in Green Bay were around that price, with the median being right at that line. Okay. But you can see that, okay, there were a few less expensive houses and a few more expensive houses. So that's what the box and whisker graph does. It groups up half the data and can really be clarifying if you're comparing two sets especially. We'll go ahead and do another one of these. Do you have any questions first? Well, we should label what I'll be looking for on your quiz, right? So take a different color and label it. Okay, so you need the title. Use a different color though, because it's really weird when I get a quiz box and whisker graph that says title, median. Okay, and then we have the median here. And then we have the first quartile and the third quartile. We have the max. We have the min. We have no vertical axis. No vertical axis, and we have a consistent scale. All of these graphs call for a consistent scale, no breaks. You're trying to show that this is a big 25% spread, that it's not all grouped up. That's what you're trying to show. And the title. Anybody have any questions before we do the same thing for the grades? Okay. So let's find the 5-number summary for the grades. Can you try and find that yourself, please? Because that is a little bit hard, and I'd like to make sure you know how to do that. There's 26 values, all listed in order. We're looking for the min, max, median, first quartile, third quartile. So min is 28, max is 99. The median, you have to average the 13th and 14th number, which we did do that in class on Wednesday. Was that 72.5? Did anybody else get that?
Yeah, I got
Okay,
that.
good. Then that leaves 13 numbers above the horizontal line and 13 below the horizontal line. So we need the 7th number then, because if you pick the 7th number up here for the first quartile, there'll still be 6 between the horizontal line and 59. 1, 2, 3, 4, 5, 6. Yeah, and 6 above that. So 59. And then below the horizontal line, you're looking for the 7th number below that line. 1, 2, 3, 4, 5, 6, 7. So from the larger values, we pick the number 85, and that leaves 6 between the horizontal line and 85, and 6 after 85. 1, 2, 3, 4, 5, 6. So hopefully those work out for you. Now we'll go ahead and graph them. Do you have any questions finding those numbers? Make sure you see me after class if you're just being shy. So box and whisker graph. Of Math 101 final grades. We have a title, and then we have a consistent scale. Let's do our scales in our scale in tens this time. So 0, 10, 20, 30. I always do this and then think I should have made it twice as big. So it would have been nicer in 5s. But now it's done, so that's what it's going to be. Okay, so mark off the 28. No, mark off the median first, right? Get your box set up. So 72.5. I'll make that 4 units tall, and remember halfway through is going to be 75, so you want to be half of half through the box there. So that's your median. And then the first quartile is at 59, so that's very close to the 60. Just this side of the 60. Third quartile, 85, so halfway between the 80 and the 90. And that shows where half of the grades fell. See how that lends clarity? Half the students were getting grades in here. And then we can see, when we mark off the max and the min, how the other quarters trail off. So maximum, 99. So put a little vertical line by 99. And minimum 28, so a little vertical line by the 28, and then a dotted line connecting your box to your max and min. Don't forget the title on the bottom, grades. So these box and whisker graphs were your class activity for section 9.2. So please go ahead and take a picture of that and upload it. And if you didn't have yours work out or you had any questions, please see me after class, because I'd like you to do well at this on the quiz on what is it, the 16th or the 18th?
It's the 16th.
So this class, it depends on what time your class meets. Online students, feel free to email me with pictures or questions.